Hello everyone. I hope you are doing all well. Can you please confirm if you can hear me?
I sent you.
Okay. Hi. How was today's contest, guys? Did you enjoy it? How many problems you guys have solved today? Nice. Thank you very much. So, I think I started the live stream about 5 minutes sooner than what was scheduled, so we should wait a little bit till the rest of you join as well. Thank you very much, Lloyd. Thank you. Yes, Codeforces, I saw that. I heard that Codeforces was crashing and you couldn't access CF. And because of that, it's written here that due to the performance of the main site for a long period, this round will be unrated. You solved 3. I see. What about the rest of you guys? Has anyone solved more than this or less than this? Any? Are you? You solved 4, Shardel. I see. If you're going to learn DP, what I suggest to you, I'm starting live streams, as you might know already, and we already have 3 sessions on DP in our topic streams. If you want, you can watch them, and right now we are on graph theory. We will get back to DP as well in the future, and we're gonna cover one topic each week, and my plan is to eventually get somewhere that we cover everything important in competitive programming, so that one can learn every important thing in competitive programming by watching those live streams, those topic streams. So I send you the link of this playlist. If you want, you can watch it. And guys, if you want, you can join for further discussions. You can join our Telegram channel or our Discord server. Telegram is my own favorite platform in social media. I really like Telegram, and also I like its founder, Paul. If you want, you can join our Telegram channel, and also if you want, you can join our Discord server here. The chess week, you have wrote your DP, your doubts on a blog related to the DP problem we took. Can you send the link of it? Maybe I can see that, or ping me there if you have a question. We don't have. I personally have Instagram, but we don't have any activity. For this channel on Instagram. If you want, maybe we can also make it. We can make a page on Instagram and cover some of the things as well. Especially because in 2 weeks we're gonna participate in ICPC. Maybe I can put something there from ICPC. My own Instagram is this, but it's personal, and it's not for the channel. But if you want, we can connect there. So yeah, maybe I can make that. That's a good suggestion. Maybe I will make that. I can, if you think that that's gonna be helpful or interesting, I can do that. So I think it's getting to the time that we scheduled the live stream, so maybe now we can also start discussing the problems. Okay, so shall we start discussing the problems? The diff4 round was difficult. Any success to learn problem solving? The best thing to do is to solve problems in Codeforces. I mean, the best way you will learn problem solving is to solve problems yourself. That's the most important thing. So I suggest, if you know some things, for example, you know C++, etc., just start solving problems and gradually you will develop. Okay, so let's start. Let me bring the problems. Let's first start from problem A. I have read all the problems and I think I have solutions. For all of them, we will talk about them one by one. So the first problem that we're going to discuss today is this problem, 2009A, minimize. You are given two integers a and b over all possible integer values of c between a and b. Find the minimum value of c minus a plus b minus c. Okay, so we have three numbers. Two of them are given, a and b are given. And then we want to find some integer c, which c is between a and b, and we want to minimize the value of c minus a plus b minus c. And if you rewrite this expression, you will see that you have, it's like you have c minus a plus b minus c, and these two c's will cancel each other, because you have a positive c and you also have a negative c. So these two c's cancel each other. And do not forget that c is greater than or equal to a, so this is a non-negative number, and b is also greater than or equal to c, so this is also a non-negative number. So the orders are exactly as this. So these two c's cancel each other, so at the end we have b minus a. So what we understand is that c does not matter. I mean, it's not important that what c is. Whatever you see, you choose for this interval from a to b, at the end you will get b minus a. So the point is that you don't need to care about any of these things. So when you get a and b, you just see out b minus a, because whatever your c is, when you set c between a and b, at the end c minus a plus b minus c is going to be b minus a. So we do not need to worry about what the value of c is. So as you can see in here, when a is 1, b is 2, the answer must be 2 minus 1, which it is. It's 1. In here it must be 10 minus 3, which is 7, and we see yes, it is 7. In here it should be 5 minus 5, which is 0, so we see that it is 0. So the only thing is that once you got a and b, you need to print b minus a, and that's all. Is it clear? If it is clear, please again use this emoji or put a plus in the chat, this 100 emoji. Nice. Okay. So nice. So shall we move on to the next problem? Yes, multiple. Nice. And by the way, guys, if you wanted to support my work, I would appreciate it if you can like the video in here or subscribe to the channel. You don't need to do this as always, but if you do that, I think that's gonna be a great support, and I would really appreciate it. Nice, thank you, Hack.js. So let's move on to the next problem, problem B. This problem says that as soon as you are playing a game and it has n rows and each row has 4 columns, and each row each row, as you know, has 4 columns, and in each one of them there is exactly one of these signs of hashtags, and the rest of the row are dots. So there's exactly one hashtag in each row, and the rest of the cells in the row are dots. You just need to print that in each row which one of the elements is a hashtag, and you have to write that from the bottom to the top. So for example, in here you should start from the bottom row. You see that it has 4 columns. The 4th column has a hashtag, so you need to write 4. Then on the row above that, it has again 4 cells. The 3rd one is a hashtag. The rest of them are dots, so it's 3. In here, the 2nd one is a hashtag, so you need to write 2. And in here, the 1st one is a hashtag, so you need to write 1. And in here, both of them are 2. And in here, there's only 1 row, and in that row, the 4th cell is a hashtag. So it's just an implementation problem. You just need to see that for each I, you need to start a 4. It depends on if you use 1-based indexing or 0-based indexing. 0-based indexing means that you enumerate the rows from 0 to n-1. 1-based indexing means that you enumerate the rows from 1 to n. So both of them can work. For example, if you use 0-based indexing, you need to have a 4 int I starting from. I write it like this as a pseudocode. It's not a complete code. I just write a shorter version as a pseudocode. You start an I from n-1 go to 0, and you just have a 4 on j starting from 0 go to 3, because do not forget, when we have 4 cells in each row, our string has indices from 0 to 3. It's 0-based indexing in strings. And we just say that if it was a hashtag, if s of I and j was a hashtag, just see out j. And we know that in each row automatically only 1 j will be printed, so we don't need to worry about it. If this happens, just see out j or j plus 1, because we are working with 0-based indexing, but we need to print in 1-based indexing, and a white space after that. And at the end of each of these test cases, you need to see out an additional endl or \n. And this way you can easily find out all the hashtags in the rows. Does it make sense? Is it clear for you? If it is, please again use this emoji or put a plus in the chats. And if it is not, let me know. In j from 0 to 3 means that? Yeah, both works if you do in order or in the opposite order. Yes, the site was like, yeah, that's correct. Okay, nice. So, shall we move on to the next problem, to the problem C? Yes, I can say it again. It was just an implementation problem. I just have a 4 on each row. For each row, I have a 4 on all the possible columns, and in each one of them, I say that if that cell was a hashtag, just see out the index of that column, and that's gonna be all. And at the end, I see out an end. So, okay. So if it is okay, shall we move on to problem C, or do you need more information on problem B? Okay, so let's move on to problem C then. Nice. So problem C, the legend of Freya the frog. Freya the frog is traveling on 2D coordinate plane. She is currently at point 0 and 0 and wants to go to point x and y. In one move, she can choose an integer d such that d is from 0 to k and jump d spots forward in the direction that she is facing. So initially, she is facing the positive x direction. After every move, she will alternate between facing the positive x direction and the positive y direction. And what the question is asking you that what is the minimum amount of moves she must perform to land on point X and Y. So we know that each time when we are facing a direction, we can go at most by K or at least by 0. I mean, we can also do not move. We can choose 0 and stay at our place. But we either look at the positive X's or positive Y's, and in each one of them we can move by at most K. And we want to get to X and Y. So this is, right now we are at origin, we are at point 0 and 0. We want to get to X and Y. And we know that we alternatively, we will face to the positive X direction and to the positive Y direction. So what can we say in here? Well, first of all, we can say that the two directions, I mean the X direction, the positive X direction and the positive Y direction can be seen as independent. I mean, I can see them as two independent things. I mean, but in the X direction, I mean, our first dimension must become equal to this X, and our second dimension must get equal to this Y. And I can see them as independent. So it doesn't matter what our X is, what our Y is. I mean, both of them individually must get to their goal. So what I can say is that for X and for Y, for each one of them, I can see that how many turns do I need. But I know that when my X must come to here, I mean, my first dimension should become this much. I'm gonna need at least say of X over K moves. Because in each move, I can go by at most K, right? In each move, I can go by at most K. So I need at least these many moves when I'm facing positive X direction. And after that, even if I face X direction more, I just stay at my place. I do not move. So what I can say, this is problem C. What I can say is that for the first dimension, I mean, when we want our first dimension to become equal to X, I'm going to need the scaling of X over K moves to get there, right? And for Y, I can also say that, can you say that what is the answer for Y? I mean, if I look at Y independently, how many moves do I need for Y to get where I need to be? What I can say about Y? It's fairly similar, right? Exactly. It's gonna be Y over K, the scaling of Y over K, exactly. So it's gonna be Y over K when I'm facing the positive Y direction. So the point is that I need to face to the positive X direction at least this much, and I need to face the positive Y direction at least these many times. So the point is that let's call this as A, capital A, and let's call this as capital B. So I need to face the positive X direction at least 8 times. And also I can say the same thing for Y. I need to face the positive Y direction at least B times, right? So I need to face the positive X directions at least A times, and I need to face the positive Y direction at least B times. And I know that I will alternatively visit these two directions. So there are two cases. Either B is greater than or equal to A, or A is greater than B. So either A is less than or equal to B, or A is greater than B. Let's say A is greater than B. We have these two cases. If A is less than or equal to B, I can say that the answer is going to be 2b. Because anyway, I need to face the positive y direction at least b times. And before each time that I face the positive y direction, I need to see the positive x direction at least once. So even though for positive x direction, I need less than that, I need less than or equal to that, maybe I need less than that. But anyway, I need to visit the positive x direction at least that many times. Because I need, for example, assume that I need to see the positive x direction at least 3 times, and I need to see the positive y direction at least 5 times. The point is that because in my first time I will visit x direction, then I will see y direction, then x, then y. Again, then x, then y, then x, then y, then x, then y. So I need these 3 x's and I need these 5 y's. But since I'm gonna need all these 5 y's, because of them I need to also see these 2 additional times for x. Therefore, I can say that when a is less than or equal to b, the answer is going to be 2b, because I need to see the positive y direction at least b times, and for that I also need to see positive x direction at least b times. So it's going to be b for x and b for y. So the answer is going to be 2b. Is it okay? So it is for the case where we know that their value of b is greater than or equal to value of a. Do you agree with this so far? Why used sale function? Yes, I will talk why sale. If it is clear, please use this emoji again or say that in the chat. Tyler D, nice. Are you a fan of Fight Club? Nice. Okay, so let me also say that why I use the sale function. Yes, that is correct. I get to there very soon. Yes, that's correct. So I use sale because assume that, what does sale mean? For example, assume that we have 2 numbers, that's the first one is not divisible by the second one. For example, 10 and 3. I know that 10 over 3 is gonna be 3.33 so on. Okay, 3.333 and so on. The floor of 10 over 3 means that just get rid of this everything after this dot, after this period, and just keep the integer value before that. So it means that round down everything you have. So floor of 10 over 3 is going to be 3, and the sailing of 10 over 3, is going to be 4, because it says that round up whatever you have. So if we have something after period, we will round them up. Why do we need sailing here? Because if we need to go at least, our x is, for example, 10. Each time we can only increase it by 3. Then we cannot have these many moves. In order to get to 10, we need to do 4 moves. We cannot do it with 3 moves. Because with 3 moves, we can at most get to 9. So for this additional value, because we cannot have 0.333 moves, we have to round it up and just have 1 additional move for that part. But the point is that for this part, after the point, we cannot have these many moves. The number of moves must be integer. So for that part, we need to have 1 additional move, and we cannot do anything else, right? Therefore, if we have to get to 10, and each time we can go by at most 3, we're gonna need 4 moves. We need to round it up. Is it clear? So that's why I used sailing. Is it clear now? So this is why, nice. So this is why we need sailing. Yes, if the value modulo k is not 0, we add 1 to it. And when you want to write sailing in C++, When you want to, for example, you have A and B, and you want to know the sailing of A over B. Well, you know, when we have two integers and we divide them by each other, A divided by B automatically gives us the floor of A over B. Right? A over B by default gives us the floor of A over B. A divided by B in C++ code gives us the floor of A over B. So when you want to implement sailing, what you can do in C++ is this. You can just add A by B minus 1 and then divide it by B. This will give you the sailing of A over B. Why? Well, the point is that if A was divisible by B, sailing and floor do not have any differences. So the point is that if A is divided by B, by adding B minus 1, you do not change anything in here. You do not change the value of A over B by adding B minus 1 if A is divisible by B. So the point is that if A modulo B is 0, it will not be added by anything. It remains the same when you add B minus 1 to A. But if A modulo B is not 0, by doing this, you will add 1 to A over B. And therefore, it is exactly equal to sailing. So whenever you want it, let me write it here. Whenever you wanted the value of sailing of A and B for any two integers like A and B, you just write A plus B minus 1 over B in C++. You just write A plus B minus 1 over B. This is how you get sailing in division. It's better if you do not use the functions, the built-in functions of C++, and you just write it by hand. I mean, just write A plus B minus 1 over B. Because the functions, it's better if you do not trust the built-in functions of C++ for everything, because you're not sure that how they are implemented, what they're gonna use, etc. So it's better if there are some things that you can do it by yourself, just implement it by yourself. The same thing is true for power. And when you want to calculate something to the power of something, it's the best if you do not use built-in C++ functions for that. And why minus 1? Well, the point is that we need minus 1 because A plus B over B is gonna always be A over B plus 1. This is always equal to that. A plus B over B, the floor of it, is gonna be always equal to the floor of A over B minus 1. But if you have A plus B minus 1 over B, the point is that if A modulo B was 0, then this is gonna be A divided by B, the floor of A over B. It does not change if A modulo B was 0, because we have added B minus 1 to it, and B minus 1 does not make another block of B's, so it's gonna remain the same. But if A modulo B is non-zero, by doing this you add one additional block, because you had at least one remainder, and when you add B minus 1 to it, one more block is added, so it's gonna be A over B plus 1. And as you see, this is exactly equal to the sailing of A over B, because the sail of A over B is also equal to the floor of A over B if A modulo B is 0, and it's equal to the floor of A over B plus 1 if A modulo B is not 0. So this is exactly what we want from the sail. So that's how we can find the sailing. And now, if that is clear, then let's get to the case where, sorry for it. Let's get back to the case where A is greater than B. Well, now can you guess that what's going to be the answer if A is greater than B? I think you said it before in here, but you can, I want the rest of you to also say it if you know. What can we do if A is greater than B? What can we do in this case? Exactly. Nice. It's gonna be 2 times A minus 1. Why? Because assume that you need 5 x's and only 3 y's. Three operations in the positive y direction. Then again, if you write this x and y's, if you need less than 5 x's, you do not need to have 5 y's. If you need less than 5 y's and 5 x's, you do not need to take 5 y's. It's enough if you take 4 y's. Why? Because assume that in this case, you're gonna need these 3 y's and you're gonna need these 5 x's. As you can see in here, we just need to take also this y as well, but we do not need to take this last y anymore because it's after the 5th x. So we do not need to take the 5th y, it's after the 5th x. So we just need to have 5 x's and 4 y's. For y's, 3 y was enough for us. 4 y's was enough for us, 4 y's, but 3 y's was enough, but we need the 4th one as well because the 4th y is before the 5th x. Therefore, we're gonna need that as well. And hence, when a is greater than y, we just need to take the first a minus 1 y's, not all the first a y's, because the 8th y is after the 8th x. Therefore, we do not need that. But the a minus 1 first y's are before the x number a. Therefore, we also have to take all those a minus 1 y's. Therefore, in this case, we can say that our answer is going to be 2 times a minus 1. And the reason is we're going to need a x's and we're going to need a minus 1 y's. And since b is less than a, we just need a minus 1 y's because b is also less than or equal to a minus 1 and we do not need more y's. Therefore, the only thing that we need to do in this problem is this. We just need to see that, we just need to calculate a and b. A is sale of x over k, b is sale of y over k. We just need to calculate them, and then if a was less than or equal to b, print 2b. If a was greater than, print 2a minus 1. So after getting x and y, we just say int of a, let's just use capital E in here as well, like the explanation that I said. This is going to be the scaling of x over k. So it's going to be x plus k minus 1 over k. Also int of b is going to be y plus k minus 1 over k. And then we say that if a was less than or equal to b, just see out 2 times b, and else, this is the case where a is greater than b, else just see out 2 times a minus 1 and And that's going to be all about problem C. Does it make sense? If it makes sense for you, please again use this emoji, this 100 emoji, or write that in the chats. Nice. Nice. Okay. So shall we move on to problem D? Okay, so let's now move on to problem D. Check once with test cases. Okay, I mean, if you see these test cases, this is 9, 11. Sailing of 9 over 3 is 3, sailing of 11 over 3 is 4. So in here, capital A is 3, capital B is 4. Maximum of them is 4. B is greater or equal to A. Therefore, it's going to be 2 times B. In this last case, X is 1 million, Y is 100,000. I mean, you might have misread this one. It is 1 million. It has 1 more zeros. It is 1 million, and it has this one has 5 zeros. So it's 100,000. I first misread it as well, and I got shocked when I saw this output. But the point is, the number of zeros are different in these two. This is 10 to the power of 5. This is 10 to the power of 6. A million over 10 is gonna be 100,000. 100,000 over 10 is gonna be 10,000. A is gonna be greater than B. Therefore, it's gonna be 2 times A, 2 times 100,000 minus 1, which is going to be this. And this way we're going to get the answer. Is it clear now? Yes, the test case was a bit hard to read in this one. Okay, so let's now move on to problem D, because I think most of you want to move on to D. This problem is saying that Satyam is given n distinct points on the 2D coordinate plane. It is guaranteed that yi is from 0 to 1. Yi is either 0 or 1 for all given points. So each yi is either 0 or it is 1. How many different non-degenerate right triangles can be formed from choosing 3 different points as its vertices? 2 triangles A and B are different if there is a point V such that V is a vertex of A but not a vertex of B. So, well, in this problem, the main thing is that first we need to see that what the problem wants. It wants a non-degenerate right triangle. Non-degenerate right triangle. Well, by non-degenerate, as you can see in the statement itself, it is written. A non-degenerate right triangle has positive area, so it means that its area must not be 0. For example, if you choose 3 points for all of them, yi is 0, then the area of your rectangle is going to be 0, so it's not going to be good. A non-degenerate means that this triangle must really be a triangle. For example, like this. This is a real triangle. A degenerate triangle is like this. If you choose 3 vertices like this, all of them, for example, assume that y is 0. Then it's not really a triangle. It's like a line. Or in other words, its area is going to be 0. So it's going to be degenerate. A non-degenerate means that it must not be like this. Or in other words, xi's and yi's must be different. I mean, yi's cannot be all the same, and xi's also cannot be all the same, which in this case does not happen. So it means that all the yi's cannot be the same. And also about the right triangle. Right triangle means that at least 1 degree must be 90 degrees. One of the angles must be 90 degrees. So we want something like this, a triangle such that at least, it is non-degenerate, and also is at least one of its angles is 90 degrees. So, well, first of all, we can see that how many classes of these triangles we might have. How many classes of these triangles we might have. First of all, I say that in these triangles, we have 2 lines. Either our yi is 0, let's say y is equal to 0 in here, and y is equal to 1 in here. We know that our points are in one of these 2 lines. And when we choose a triangle has 3 points. We know that 2 of them must be in one of these lines and 1 of them in the other one. The only way that it's possible is that if it's 2, 1. Either 2 in here and 1 in here, or 2 in here and 1 in here. It must be one of these two ways. Let me use another color for this one. Either it must be like this red one, that's two of the points are in y equal to 0, 1 in y equal to 1, or in other way around. 2 at y equal to 1 and 1 at y equal to 0. So it's one of these two ways. So this is the first case. I mean, how many? I mean, we have 1 point at y equal to 0 or 2 points at y equal to 0. And then for y equal to 1, we have the rest of the points. So in here, we have two cases. So one of them is that we have 2y equal to 0, 1y equal to 1. The other case is we have 1y equal to 0 and 2y equal to 1. Now the next important thing is in here is that the angle, the 90 degree angle, it is definitely corresponded to one of the vertices that we choose. But it's corresponded to which one of the vertices? I mean, there is a case that that 90 degree is corresponding to one of the vertices in the side that we have 2 points. So we know that in one of the lines we have 2 points, in the other one we have 1 point. Right? We have two cases. These two cases are the most important ones. Either that 90 degree vertex is from that side, that line that has two vertices, is from the side with two vertices, or it is from the side with one vertex. Right? It is in one of these two categories, right? It's either in the first case or in the second case. And this is the most important cases. I mean, the point is that in these two cases are so similar that we do not need to separate these two cases. We just know that, okay, one of the lines have 2 points, one of them has 1 point. We just know that. Now the main important thing is that 90 degree vertex is in this part or in that part. It is also possible that that vertex is in here. These are both possible. And the point is that we can solve these two. The point is that we can solve these two cases separately. So we need to see that in how many ways we have that 90 degree vertex in the side with two vertices, and in how many ways we have a 90 degree angle in the side in a vertex with that is in the side with one vertex. Is it clear so far? I mean, so far everything is clear. I mean, we had two cases. We know that one of the lines has two vertices, one of the line has one vertices. Now we know that one of the vertices have 90 degrees. Now the question is that 90 degrees in the side with two vertices or in the side with one vertex? If it is not clear, let me know in the comments to explain again. Otherwise, either use the emojis or write in the comments, in the chat. We do not want to brute force now. Nice. Because yes, brute force might give you TLD. So we not want to solve these two parts separately. Now let's first solve the first part. I mean, if we just solve these two problems separately, we can just add the answers. We can just add the answers, and then we're gonna have our final answers. So there's one problem in here that we want to solve, and one problem in here that we want to solve, right? One problem in here that must be solved, and one problem in here that must be solved. We will solve both of the parts and then add up the answers. So now let's move on to the first parts and let's solve them. Solve these parts. Okay. Let's solve the first parts. What can we say about the first parts? Well, the point is that two of the vertices must be chosen from one of the sides. right? Two vertices must be chosen from one side, and that's 90-degree vertex is in that part. For example, assume that this is the 90-degree vertex. Well, obviously you can say that the other vertex must be this one. For example, assume that in here y is 0. This one, for example, x is 3, in this one x is 7. So we have 3 and 0, and we have 7 and 0. The other point is definitely gonna be 3 and 1. That's the only possible case, that we will make a 90-degree vertex. So this case is gonna be, we need to choose two vertices such that their x's are equal, and another vertex anywhere. So you need to find, for some x, you need to find out that if we have x and 0 and x and 1, then for these two, we can have these two vertices with any other vertex. For any other vertex, either it is here or it is here, anywhere. All of them will make a non-degenerate right triangle. Or if the vertex is here and the other vertex is here, again it's like that. So each one of them give us one answer for the problem that we're looking for. In the cases that we choose three vertices, one of the vertices that is in the side with two vertices is gonna have 90 degree. It's gonna have the angle of 90 degree. So we just need to find, for some x, that we have x and 0, and we also have x and 1, we need to find out how many other vertices exist. There's going to be exactly n minus 2 other vertices. These two vertices, with any of those n minus 2 other vertices, will make a non-degenerate right triangle. So for each one of these, we add n minus 2 to our answer. For every x that we have x and 0, and we also have x and 1, we add n minus 2 to our final answer. And this way we can get the final answer. Is it clear for this case? This was the case that 90 degree is from the side with two vertices. We haven't got to the second case yet. We will solve the second case afterwards. If it is clear, please again say it in the chat or use the emojis, and then we will move on to the second case. We can implement the codes as well, but I think because right now we have limited time, maybe it's best to get to solve other problems as well. If I was participating in the contest, I would also show you my code. But since this time I didn't participate in the contest, I don't have the codes. But if needed, whenever needed, let me know if you wanted to see implementation. I can show you other codes right now. And if you really need, I can, for some problems, also start implementing whatever you choose. If you want me to implement or move on to the next problem. Okay, nice. So let's now talk about the second case. So the first case is solved now, right? The first case is now solved. Now we need to solve the second case. In the second case looks more complicated, but it is not really complicated. Well, the point is that assume that you have one vertex in here, and you want to choose two vertices from the other side such that this degree of this vertex is gonna be 90. Okay, this is what you want. Well, the point is that if you choose another points from the other points will have the same x. I want to first say that the other point must not have the same x, because we know that if the other point has the same value of x, then the vertex that has 2 points is gonna have, the side that has 2 points is gonna have the 90 degree. I mean, if one of the vertices in here, we know that the other vertex must be also chosen from this side. For example, this is something in here. Then this degree will be 90, not this one. So the point is that first of all, the other one cannot have the same x, right? Because otherwise, if it has the same x, then that one is going to be with 90 degrees. Because the other vertex must be also chosen from this other line, then this one will have the 90 degree angle. So first we know that that does not happen. So now let's draw this line. We know that the points are either to the left of it or to the right of it, right? But now again we can say that if it is not possible that both of them are from the same side, because if both of them are from the same side, the degree, the angle of this vertex is definitely going to be less than 90. Because even the angle of this with this line, I mean any points, the angle of any point with this line is going to be less than 90. But then obviously the difference, when their angle with the red line is less than 90, the difference with each other is less than 90 as well. So both of them cannot be from the same side as well. So far we have showed that if we write this line, one of them is to the left side, one of them is to the right side. Do you agree with this? If you agree with this, please again use the emoji or write that in the chat. So far we showed that these two vertices must be from the same, from different sides. Nice. And now the main fact comes. This fact destroys this problem. So there is a fact that will destroy, literally destroy the problem. And what is that? Well, the fact is that those two vertices must be exactly in here. Their difference of x must be exactly 1. One of them, if this is x and 1, one of them must be exactly x minus 1 and 0. The other one must be exactly x plus 1 and 0. So in other words, they must be the adjacent x's. If this is x, these other vertices, one of them must be in x minus 1, one of them must be in x plus 1. Okay, this is what I got from this problem when I saw it. Why? Yeah, sure. The link of the Telegram channel is here, yeah. So what is the reason of that? The reason of that is that if you choose any other vertices to the left of it, you know that this degree that you have is gonna be more than 45 degrees. We know that if we consider this vertex, the degree between these two vertices, I mean, let's consider first this yellow line between these 2 points. The degree of this yellow line with this red line is gonna be 45 degrees. But if you choose any other vertices in here, let's show it with green color. If you use any other vertices in here, the degree of this green line with this red line is definitely more than 45 degrees. So the point is that the minimum that you can get is always 45 if you choose the vertex next to it, exactly one next to it. But if you use anything with more distance, the degree is going to be more than 45. Also about the right parts, the minimum you can get, the minimum degree you can get is if you choose this vertex, and this way you get 45 degrees. And if you choose any other vertex to the right of it, you're going to get more than 45. So the point is that from each side, I mean at the ends, the degree of this vertex is going to be the sum of the degree of these left points with this red line and this right point, the line to this right point with this red line. We need to sum these two values up. The sum of them must be 90 degrees. So both of them must be exactly 45 degrees. If they are greater than 45 degrees, the sum will be greater than 90. So it's not possible. So the only case is that if you choose these 2 points from x minus 1 and x plus 1, that's the only case. So therefore this case can be easily solved as well. How can it be solved? It can be, we can say that if we choose one vertex from one side and we want to choose 2 vertices from the other side such that this angle will be 90, those 2 vertices from the other side, if this one has its first dimension is x, those 2 other ones must be x minus 1 and x plus 1. So for each x and y, we need to check x minus 1 and not of y, and x plus 1 and not of y. If both of them existed, we add 1 to the answer for this case. Is it clear now? Yes, problem totally destroyed by this fact. If you're again okay with that, please use the emojis or say that in the chat. ID till G1, G2, G3 are way above even D3. Yeah. Nice. So is it completely clear? Nice. Great. Great. No. For each one of them, we iterate over all the points. I mean, for each one of the cases, it's possible that, you know, we had 2 cases. One of the cases, we don't care about our code, our points is from x equal to 0 or it's from x equal to y. The point is that we said that these 2 cases are very similar. So we don't need to separate them. These 2 cases are so similar. So we do not need to separate them. What we separate by is that if we know that one of the lines, we have 2 lines, one of them is going to have 2 vertices, one of them is going to have 1 vertex. The point is that 90-degree vertex is from the part with 2 vertices or from the part with 1 vertex. That was what we were concerning about. And we solved these 2 parts separately. We said that if the side with 2 vertices, if from that side we're gonna get a 90 degree, then it's enough to find out 2 points such that their x's are equal and the y of one of them is 0, the y of other one is 1 definitely. And then they can be with any other vertex. So they can come with any of these n minus 2 other vertices. So this is how the first part can be solved. And for the second part, we have a for on all the vertices. For example, it is at x and y. The point is that the other 2 vertices must be x minus 1 and not of y. By not of y, I mean that if y is 1, this one must have its y to be 0. If y is 0, this one must be 1. So it's gonna be x minus 1 and not of y, and this one is gonna be x plus 1 and not of y. If both of them existed, we add 1 to the answer. Is it clear now? And this way, at the end, we add up the answer of these 2 problems. We add up the answer of these 2 problems, and this gives us the final answer. If we add them, we get the final answer of this problem. Nice, thank you. So, is it clear now? If y is not 1 and it is some t, we have to consider x plus t. It's not necessarily x plus t and x minus t. It's the point is that the difference must be exactly 1. I mean, it must be x plus 1 and x minus 1 if we're gonna want 90 degrees. Do you have a solution for 90? No, that's gonna be harder. I mean, that is something that you can think about. But for this problem, this approach won't work on that problem. So this approach is only for this problem right now. That would be more complicated, and we can as a bonus, you can think about that. But that's gonna have another solution as well. I mean, the solution of that will be way different. So this problem, even though it looks like geometry, it is not really geometry. With just some facts, you can remove this geometry part. I mean, with just some facts, it's just a counting problem. Because it's very simple geometry, and with that, you don't need geometry anymore after that in this problem. Okay, is it clear? About E and F, we get to E and F right after this. Do you want to see the code? Okay, if you want, I can show code, yes. Let's see some code from you people. It's problem D. Oh. So, some people have coded with Python. It's interesting. So let's see this solution. It gets T, and for each test case, it has, let me make sure, okay. First, it gets X and Y, and if this Y plus 1 modulo 2 is equivalent with not of Y. So, I can say that this is that not of Y that I was talking about. If Y is 0, that gets 1. If Y is 1, that gives us 0. Or I could also say 1 minus Y. That would also work. All of this would work. Not of Y, 1 minus Y, or Y plus 1 modulo 2. So it says that, it first says that if the other points with the same X existed, so you see that it has the same X, but its Y is different. It says that if that point existed, just add n minus 2 to the answer, as I said. In that case, that we had 2 points with the same X at different Y's, we add n minus 2 to the answer. And then we say that he's saying that a of x plus 1 and okay, he's checking that if x was 1 and a of x plus 1, and let me just see what x equal to 1, non-zero. Okay, yes, he just checks that if x is non-zero to be in bounds. I mean, he just checks x is non-zero so that x minus 1 wouldn't be outside of the bound of the array. So this is for just for checking that this x is for checking that this x minus 1 wouldn't be minus 1 and we don't get a runtime error. That's the only reason of this x. If x and then a of x plus 1 and y plus 1, the other y, this is again not of y, the other row. If this existed and x minus 1 and the other row existed, then we add 1 to s. And then also we say that if x greater than or equal to 2 and let me see what does it say, x greater than or equal to 2, a of x minus 2 and 1 and a of, let me see what does it say. This case is again if they have the same y's, right? Yes, these are again the same cases because you know the point is that in here, because we do not have order, let me show it in here. In these 3 next ifs, he's checking this case, but the point is that because he's seeing them all in the order of inputs, maybe from these 3 vertices, the last vertex that comes is this one, maybe the last vertex that comes is this one, maybe the last vertex that comes is this one. So because he's visiting the vertices in the order of their arrival in the inputs, only when all these 3 vertices are given to us, we can add 1 to the answer. So in the next 2 ifs, he's checking that when he gets this vertex, he checks if these 2 vertices exist and then add 1 to the answer. But if you get all the inputs at the beginning, you don't need to do this. You can just check it for this vertex. So because he is going in the order of arrival of the vertices, whenever he gets one vertex, he has to check all these 3 cases. If this, for example, he also needs to check that if he gets x and y and this one is x and y, he needs to check x plus 1 and not of y. This is going to be x plus 1 and not of y. and this is gonna be x plus 1 and y. If this is the last vertex that has came, and if that came, we need to see that if both of these vertices existed, we need to add 1 to the answer. So that's why you see in here that he says that he checks that if x plus 1 and the not of y, and also x plus 2 and y exist. And in this case, he checks x minus 2 and y, and x minus 1 and not of y exists. Because this is all of these 3 lines are for the second case, because we have 3 points, each one of these 3 can come last, and for each one of them we need to add 1 to the answer. I mean, for each of the cases we need to check which one comes the last. And this is for the first case. If for the same x, both of the vertices existed, we need to add n minus 2 to the answer, and at the end we just see out the answer. Is it clear now? Is the code okay, clear? If you are okay with that, please again use the emojis or write that in the chat. If you are okay, we can move on to problem E. And if it was not clear for you, you can let me know in the chats. So, Satyam, yeah, that's right. Okay, nice. So, let's now move on to the to problem E. Thank you very much. Thank you very much. So let's move on to problem E now. Well, the problem E says that we have a super duper large array consisting of integers k, k plus 1, 2, k plus n minus 1 in this order, and we want to choose an index I such that the sum of a1 to ai minus a of a sub I plus 1 to an is minimized. And you have to find that value. I mean, you want the absolute, you want the difference between the sum of this prefix and this suffix to be minimized. So, in other words, we can say that for problem E, we have this array k, k plus 1, 2, k plus n minus 1. So its length is n, k, k plus 1, 2, k plus n minus 1. This is our array. So I show my array in here. This is my array. The first element is k, the second element is k plus 1, the last element is k plus n minus 1. You want to split it into two arrays such that the sum of here minus the sum of here, the absolute difference, the difference between these two values, the sum of this prefix and the sum of this suffix, is going to be minimized. The difference will be minimized. How can you do that? Is there any issue with the Discord link? You can't join. I mean, if there's an issue, maybe I can change the link. It sometimes expires. For me, it's working, but I don't know. Maybe it's because I'm already. I mean, it can find the group for me, but. Okay, so can you get your notes for the solutions? If it needs anybody, yes, I can also share my notes, if it helps. So we want to find a prefix such that the sum of this prefix minus the sum of this suffix is going to be a minimus. It's freeform, the default app on iPad. So how can we do that? Well, the point is that if you find the first point, I mean, we know that if we choose these prefixes, I mean, we want to choose a prefix and a suffix. Well, it's like we want to maximize the minimum of these two values. I mean, we have two values. One of them is less than the other one. It's better if we try to maximize the one that is smaller than the other one. If we try to maximize the one that is smaller compared to the other one, it's going to be better for us because these two numbers will be closer to each other. So the point is that until some point, if you choose prefixes like this, your prefix is going to be way too small, and that's going to be bad for us. And also, if you choose so much to the right, your suffix will be too small, and again your difference is going to be large. So let's say that for each line, if the left point is going to be smaller, we will write it with red, we will draw it with red, and if the left point is larger, I mean left part, the prefix is going to be, sum of the prefix is going to be larger than the suffix, we're going to draw that line with the blue color. So we have several lines, some of them are red, some of them are blue. We know that until some point our lines are going to be red, and afterwards our lines are going to be blue. Okay, until some point they're going to be red, from some point they're going to be blue. So the point is that between all these lines, the best lines that we can get is one of these two lines, the last red one or the first blue one. We need to either take the last red one or the first blue one. Why? Because among all the blue ones, we know that the smaller one, a smaller part is going to be the right part. So it's better if we try to maximize the right part. So among all these blue lines, it's the best to choose the one that is to the left. Because in this one, the sum of the right part is maximized. And among all of them that are all of these red lines, it's the best to choose the one that is to the right. Because this way we will maximize the sum of the red parts. Did you understand what red lines and what blue lines are? I mean, I said that when we have an array, when we split it from somewhere, either the left part is the smaller than the right part, or the right part is smaller than the left part. For example, if the left part is smaller than the right part, I will color this line as red if the left part is smaller than or equal to the right part, or smaller than the right part. And I will write in blue, I will color them with blue if the left part is greater than or equal to the right part. So this is if the left part is greater than or equal to the right part. This red color is for the case where the left part is gonna be less than the right part. So as I said, when we have two parts, we want to maximize the minimum one if we want to make their difference to be minimum. We have two numbers, the sum is constant. When we want to minimize their difference, we need to maximize the minimum one, right? We want to maximize the minimum one. We have two groups. One group is the sum of the numbers from A1 to AI. One group is the sum of the numbers from A sub I plus 1 to A sub n. We want to minimize the difference between these two, right? At the end, we care about the differences. Since we care about the absolute value, I mean, you see that we have the sum of the numbers from A1 to AI here, and the sum of the numbers from AI plus 1 to AN here. And we subtract them from each other. I mean, just assume that this is inside the brackets, then all these minuses are positive, are pluses, and these ones are also in the brackets. So we have two groups. We have the sum of the groups, and we want to minimize the difference between them. I mean, the absolute value of the first one minus the second one. It means the difference, whatever. So we want to maximize the one that is less than the other. So we have these two groups. We want to minimize the difference, right? We want to minimize the difference. And when we want to minimize the difference, what we can say, it means that we want to maximize the minimum one. Maximize the minimum one. Because as much as the one that is smaller, if one of them is smaller than the other one, if for the one that is smaller, we try to maximize it, it's gonna be better for us, because this way the difference is gonna be lower. So yes, this way we're gonna make them as close as possible when we make the smaller one greater. So these red lines are for the ones that our final value inside this absolute value, I mean the value inside is gonna be negative, and blue lines are when this is a positive, I mean this left part is gonna be greater than the other one. At the end all of them are gonna be positive, but I'm talking about what is inside. So I say that for these red lines, I can have that, I can draw, I can color each of these lines. If they are red, it means that the sum of the left part is greater than or equal to the sum of the right part. Sum of the left part is smaller than the sum of the right part. If they are blue, it means that the sum of the left part is greater than or equal to the sum of the right part. So I can say that among all the lines that are blue, in all of these lines that are blue, I know that the minimum one is the one to the right of them. So it's the best to choose the leftmost one of them, because the smaller part is going to be maximized this way. And also about the red lines, it's always the best to choose the last one of them. So we have only two candidates, and these two candidates are adjacent. If we find the first place that the sum of the left parts is going to be greater than or equal to the sum of the right parts, or in other words, we will find the first blue line, if we can find. If we find the first blue line, I mean the first part, the first point that we split from there, the left points, the left part is gonna have a greater sum than the right part. The answer is either this one itself or the one before that. I mean the best parts, the best point to split from is gonna be either this point or one less than that. And to find the first blue point is only enough to do a binary search. We just do a binary search and we find the first time, I mean we have this in here, our L is K, our R is K plus N minus 1. I mean this is L and R of the interval itself. And then we have some low and high for binary search. Each time we can check a new part and we can find the sum of these two parts. In order to do that, first you need to implement a function like name getSum, that it gets two values, L and R, and it has to return. I mean this way your code would be simplified and way easier to understand. This sum, this should return, this returns L plus 1 to R. So you want to do this. You want to implement a function that given L and R will return the sum of everything from L to R. How can this function be implemented? How can I find the sum of the numbers from L to R? It has a mathematical formula. N times n plus 1 divided by 2, that's the sum of 1 to n, that is correct. But if we just... Yeah, there are two ways to calculate it. One way is to just find out what is the sum of 1 to r. One way is that we can say that the sum of L to R is equal to the sum of 1 to R minus the sum of 1 to L minus 1. And then it's similar to prefix sums. This way we know that this is R times R plus 1 divided by 2, this is L minus 1 times L divided by 2. And we can subtract these two from each other, and this way we can get the sum of these parts. There's also another formula that we can say that how many numbers do we have? We have R minus L plus 1 numbers in total in this interval, because it is a closed intervals. sorry for that. Let me my app sometimes crashes, so let me bring it back again. Okay, so I'm just saying that we have r minus l plus 1 elements, and for each one of them we can take the average of L and R. When we're calculating the sum, we can also do this. We can say that R minus L plus 1 elements, and for each one of them we can take the average of L and R. So we can also say this. We can just simply return R minus L plus 1 times L plus R, and do not forget to use long. You can either multiply 1 LL in here or take everything as long. So R minus L plus 1 times L plus R divided by 2. This way you get the sum from L to R. Is it clear? Is this function clear? This function helps us to simplify our code. It gets two numbers, L and R, and returns the sum of the integers from L to R. Is it clear? Nice. So now that you have this, you can simply use a binary search, and each time you can use this function, you have this K, and in here you have K plus N minus 1. Each time you can have one of these lines, check out one of these lines, and find out if it is red or it is blue. You can easily, using this function that we implemented, see that what is the sum here, and also see that what is the sum in here. Okay, and then subtract them from each other. You can easily then subtract them from each other and see that which one is greater. I mean, the result is positive or negative. You can also do it without subtract, and you can just see that if this sum is A, this sum is B, you can just compare A and B. If A was greater than B, it means that this line is a blue line. If it is greater than or equal to B, otherwise it is a red line. So based on that, if it was the first case, your high comes here and you will search in this interval then. If it is A is less than B, your low comes here and you will search in this interval then. Anyway, you can use binary search this way. Binary search to find the first blue line. And once you find the first blue line, then you can see that, okay, this is my first blue line. You can see that what is the answer in here. Again, using the function we implemented, you can easily see that what is the sum of these two parts. And just take it minimum, which if we were taking the previous line, we will also see that what is this sum and what is their difference. We have two values then, and we print the minimum of these two. And this way we can find the answer. Is it clear? We can also show code for this, but I am afraid because we don't have much time left, I am afraid that we don't get to problem G as well. Do you need code, or do you prefer if we get to the next problems as well? Whatever you choose, I'm okay with both. I'm just afraid that we won't have enough time for the harder problems. But if you need code, that's completely okay. We can move on to the codes as well. You can also do ternary search, but it's not. It's not very wise to use ternary search because it's more like binary search. I mean, when you can easily solve the problem with binary search, doing ternary search is not useful. And most of the times, most of the problems that can be used with ternary search can also be solved with binary search. So most of the times ternary search has no points, especially when we're working on integer and a distinct structure. So we're not working with doubles or anything. Everything is integer. Okay, I think there are 2 votes for code. I mean, Hehe voted 3 times. And 3 votes for next problem. But anyway, because of you two, I will show you the code very shortly, and then we will move on to the next problem. So very shortly, I will show you the code very quickly, and then we will move on to problem F. So let's see this code. You know, as you see in here, for each test case, he has just implemented the sum function that we talked about. He calculates the sum of the values from S to E. As you saw in what I wrote in here, is S plus E times E minus S. Its length times the average of the first one and the last one. This is S plus E divided by 2. And we put divided by 2 at the end because we know that the parity of these 2 values are different. Therefore, one of them is even, and this. When you put division by 2 at the end, you will get an integer at the end. And then in here, you have a binary search. Each time he checks if f of k and m is less than this, he puts L equal to m plus 1, otherwise R equal to m. At the end, he has 2 options. He calculates the answer for both of the options and subtracts. To calculate them, he subtracts the f of these 2 parts, and then the minimum of these 2 is gonna be our answer. And this way, if you just implement this, you will get accepted at the end. And it is a very short code as well. So it's gonna have a very easy code. So you first just implement this sum function and then do this binary search to find out the answer. Is it clear? Is Yan your friend? Yes. Yes. Yes, the code was very clean and neat. I really liked the code. Yes, nice. So, if everything is okay, let's now move on to problem F. Okay. Sure. Let's now move on to problem F. The problem F says that we have an array A of length n. Let's denote C. Let's see I denotes the ith cyclic shift of A. And by cyclic shift, it means that, you know, we just shift everything. For example, for some x, we first have ax to an and then a1 to a sub x minus 1. And at the end, we set array B to be the concatenation of all these cyclic shifts. The concatenation of all these cyclic shifts, the first one is A itself, the second one starts from 2 and has A1 at the end, and so on. You have Q queries. In each query, you need to find out the sum of an interval in this array B. Okay, so this is what the problem wants from you. So in this problem, what I want to do is to use prefix sums. Prefix sums are going to help a lot to solve this problem. Has anyone solved it with anything other than prefix sums? If you also solved it with prefix sums, let me know. And if you have solved it with another thing, also let me know. But what I want to do is to use prefix sums. And if you're not familiar with prefix sums, let me also send you a video that I explain prefix sums in details. I almost said everything that you need to know about prefix sums in it. So let me. I highly encourage you to watch this video about prefix sums. In here, I explained everything necessary to know about prefix sums, and that can help a lot. About segment tree would also work, but prefix sums is easier than segment tree, and it's an overkill to solve a problem that can be solved with prefix sums to solve with segment tree. So, we have all the cyclic shifts of, just to explain it again if you didn't understand it well, we have all the cyclic shifts of A1 to AN, and we are concatenating them to each other, and then we're gonna have a large array at the end. The size of the array is gonna be n squared because it has n subarrays of length n, so its length is gonna be n squared. And then in this array you are given L and R, and you have to say that what is the sum from L to R. Well, the point is that, the main point in here is that in this problem you're gonna have several blocks. I mean, your array is of size n squared, but we should not forget that this array is still the concatenation of n arrays of length n. So it has like n blocks. It has n different blocks. And when you want to find the sum of some interval in it, some blocks completely lie inside that interval. And for those blocks, we know that what is their contribution to the answer. The contribution of these blocks to the answer is just equal to the sum of the array. I mean, if we define the variable sum as the sum of all elements in A, I from 1 to n, ai, if we define it like this, then for these intervals that lie completely inside, we know that their contribution to the answer is as much as sum, because it doesn't matter what their order is. Their sum is always constant. We just change their order, but their sum remains the same. So for every block, for all of these blocks that completely lie inside the interval, their sum does not change, right? So we know that what is their sum. Only we have a prefix and suffix that partially covers a block, some part of a block. I didn't understand, how do we form this array? The array is relatively simple because, for example, assume that your array is gonna be, for example, 1, 5, 2, 3, for instance. Then your array B is gonna be all the cyclic shifts of A. C1 is 1, 5, 2, 3. C2 starts from this 5. It's gonna be 5, 2, 3, 1. These are all the cyclic shifts of your array. C3 is gonna be 2, 3, 1, 5. C4 is gonna be 3, 1, 5, 2, and B is gonna be the concatenation of C1 and C2 and C3 and C4. So it has 4 blocks of size 4. So its size is gonna be 4 to the power of 2, n to the power of 2. So your B is gonna be 1, 5, 2, 3, then 5, 2, 3, 1, then 2, 3, 1, 5, and then 3, 1, 5, 2. So this is what we have. This is our array B. And in our array B, we want the sum of some interval each time. We want the sum of some interval each time. You need to say that what is the sum of, we are given some interval, and we need to say that what is the sum of this interval. And the point is that it still exists of some blocks. So we have several blocks. We have 4 blocks. And we need to say that we know that some of the blocks completely lie into our interval. For example, in here, these 2 blocks completely lie inside our interval that we're looking for. So we know that for them, the sum of this in here, our sum is going to be 1 plus 5 plus 2 plus 3, which is going to be 11. For these 2, we know that sum or 11 will be added to our answer. Their contribution to our answer is going to be sum or 11. And only from the first block and the last block, some part of them are going to be inside our interval. So the first and the last part, some prefix and some suffix, are part of an interval, a part of a cyclic shift. And a part of a cyclic shift is definitely an interval of the initial array. It's going to be a cyclic interval of the initial array. Maybe it's going to be like this. For example, start from here and go till here. So this is also a cyclic interval of the initial array. So each time it's like for 2 parts, we need the sum of an interval in an array, and that can be easily calculated with prefix sums. And this way we can simply find out the answers for each of these parts. It's just something that we need to just see that what is this suffix of this cyclic shift, what is this prefix of this cyclic shift. We need to see that from which index to which index we want the sum. And then using prefix sums, we can easily find the answer. And then we have everything. So we can just use prefix sums to find the answers of everything. Is it clear? And in order to find out the blocks, it's just also enough to just when we have some L and we have some R, we need to just see that what is L modulo N and what is R modulo N. And if we know them, then they will easily help us to find out the answer. I mean, by L modulo N and R modulo N, we can easily find out the blocks. And when we know the blocks, we know that for 2 blocks, we want the sum of a part of them, and for the rest of them, we just want the sum of the whole thing, which can be easily calculated. Okay, shall we move on to problem G now? No, it does not make the solution Q times N. I'm using prefix sums. So each query will be responded in O of 1. I'm using prefix sums. I have 2 intervals. For these 2 intervals, I can calculate their sum in O of 1 using prefix sums. So in O of 1, for example, assume that you have an interval, you want to find the sum of from index, for example, 3 to index 11. You just find this in O of 1 using prefix sums. You don't have a 4 on all of the indices. So you have an interval here and you have an interval here, and these parts are complete. So you can easily find out that how many blocks lie completely inside. For them you add sum, and for the block at the beginning and the block at the end, you have 2 intervals. These intervals can be easily calculated using prefix sums, and by adding the prefix sum you will find the final answer. So your solution at the end is going to be O of N plus Q. Because for each query you find the answer in O of 1, you just need to find out prefix sums, the sum of an interval, and that can be easily calculated. So you're going to have the answer. Is it clear? Nice. You're welcome. Okay, so the next problem is problem G, if you're okay with problem F. For problem G, we have 3 versions for problem G. I will explain them all together, and I will explain the solution of all of them all together because they are fairly similar. And this is what came to my mind after reading the solution. If you had any better solution or anything, you can also say that. But let's first see that what problem wants. It says that you have an arbitrary array B and you can perform the following operation any number of times. Select an index I and change its value to any integer that you desire. And denote f of b as the minimum number of operations you need to perform until there exists a consecutive subarray of length at least k in B. So you want to make a consecutive subarray of length at least k. So you need to have length at least k such that these elements are going to be consecutive. So you have this array A of size n, and you ask q queries. In each query you must output this value for every interval of length at least k, you need to say that what is the f of that, what is the value f of that interval. The only difference with versions G1 and G2 is that in G1, your R is equal to L plus K minus 1. So you're gonna need this sigma only has one value, f of one value is important. And let me see that what G2 was. I think in G2 also, the difference is that, you know, in G1 and G2 we have one sigmas, only we have 4 on the beginning. And in L1 only one interval is important. In L2 we have several intervals. In G2 we have several intervals, and in G3 we're gonna have 4 on both sides of the interval. So we will see that how they are different and how they all can be solved. So let's talk about this. Well, the first thing, let's talk a little bit that what does this problem say. You have several values, several AIs, and the point is that for each I, if you just store the value of AI minus I, let's try to store the value of AI minus I for each I. Instead of AI, keep track of AI minus I. Why I say that? Because if you want to make a subarray consecutive, if you want AIs to be consecutive, it means that AI minus I's must be the same. So the point is that by taking care of AI minus I, you just need to make everything equal, because making them consecutive might look a bit complicated. But when you subtract I from each index, now you want to make everything equal. You want to make a subarray of length k equal, right? And you know that you want to just make a subarray of length at least k equal. So you don't need to make all of them equal. Whatever the length is, it's just enough to make a subarray of length k equal. So first of all, initially you can store that for every subarray of length k, how many operations is needed to make them equal. And we are just talking about AI minus i's. As I said, AIs are not important anymore, because for AIs we need to make them consecutive, but for AI minus i's we just need to make them equal, okay? So what I say is that for each k elements, how many operations we need? How many operations we need for AI minus i's? The point is that when we're talking about AI minus i's, we can just see that what is the maximum element that we've seen. If we're talking about an interval of length k and we want to make all of them equal, it's the best to make them all equal to the elements that has appeared the most in this interval. So for example, for some x, if x has appeared the most in this interval, we just keep track of that. We try to make everything equal to x. Okay. So the point is that we need to keep track of that. In each of these intervals, how many of each element has appeared, and we need to store that what is the maximum one of them. So we can just keep track of the CNT of one of them, and we can, each time when we iterate, each time it's like we add an element in here and we remove an element from this side, we remove this one and add this one instead. And we will keep track of the CNTs, and we can also keep track of what is the maximum CNT that we have. For example, we can have everything in a set, and this way we can each time see that what is the maximum. This way, for every k element, you have an array of length n minus k plus 1, and for each interval of length k, you know that how many operations is needed to make all of them equal. Then in problem G1, you just need to answer what is a value of one cell. That is very easy. Once you calculate it, you have an array. Let's call it ans1, ans2, 2, ans sub n minus k plus 1. For each interval of length k, you'll have that how many operations you need to do to make all of them equal. And the point is that in the first one, you just have some index I and you need to say that what is ans sub I. In the second one, you have an interval and you need to find out the sum of an interval, kind of. I mean, you just need to find the sum of an interval. Okay. And in G3, you have an interval. And the point is that because this time our intervals can have length greater than k as well, when an interval has length greater than k, its answer, the answer to that specific interval, I mean, if we want to make a subarray of length k, it's going to be equal to the minimum of all its subarrays of length k. So it's like we are considering an interval in here, in our array ans, and in our array ans, for each subinterval of this interval, for each of subintervals, we want to see that what is the minimum of this subinterval and add that to our total answer. Does it make sense? So when we are answering an interval, the question is this. You are given in G3, the question is, so G1 and G2 are very easy to solve. G1 is just, we need to see out ans sub I. In G2, we have an interval and we need to say that what is the minimum in that interval. Sorry, what is the sum in that interval? So G2 can also be, G1 is just C out ans I, G2 is just a simple prefix sums, because we want the sum of an interval. G3 is going to be a bit more complicated, because in G3, we need that when we have an interval L to R, for every for every subinterval of L to R, for example, I and J is a subinterval of L to R. For every of these subintervals, we need to see that what is the minimum value among ans sub I to ans sub J, and then add that to our answer. For each I and j, we need to see that what is the minimum of these values and add that to our answer, right? So the question is going to be this. For every subinterval, you need to find out what is the minimum of that subinterval and add that to the answer. Is it clear so far? Do you have any hesitations so far? If anything is not clear, let me know. And if so far is everything is correct, is okay, the rest of it is kind of classic as well. I think it can, for example, I didn't think a lot on this, but I don't think it is very challenging to find this out. Once you break the problem into this state, if you look at it like this, you have an array. Each time you are given an interval, and you have to say that for each subinterval, if you take the minimum of everything, what is going to be the sum of everything at the end. And this is kind of classic, and I think that for every node of your segment, you can have a segment tree. I'm not sure if you need to solve it offline and sort everything by L, or you can also do it without that. I will definitely show code, yes, sure. So that we will also find a more precise solution. But anyway, either that, or we need to see that for any interval, for any segment, we can see that what is the sum of this segment, and we just need to merge them, and maybe merging them would be a little bit challenging, but it's going to be possible. So I think like this, it's going to be easy to solve. I didn't spend a lot of time because I know that I have encountered problems similar to this, and I know that this is not going to be very challenging. But the main point was to get here and to find it out. Now we were going to also, as you said, we were going to see some codes to also talk about a more precise solution. Let me also bring someone's code for that. Wait a minute. the codes that I see are a bit messy, but it's okay. Let's see some code for it. I also suspect that the solution must be messy. It has some challenge. I mean, theoretically, these problems can be solved easily, but maybe they're gonna have a lot of things that you need to code. So as you see in here, again, right, what we discussed, first we set ai minus equal to I, because that is needed because this way everything will be cleaner. This way we need to make things equal. And then ai plus equal to n, I believe that he has done that to make everything positive. Do not have any negative number. And then he has L and R, and he subtracts R by k minus 1. I again suspect that because he's fixing the start of that interval of length k, I mean where that interval of length k can start. It can be start from L, and it can also start from this new R that we have. This is why this is needed, because when we calculate the new array, we are looking in that specific interval. And he has QR dot push L, R, and I. Because of this line, I suspect that he has solved it offline. So rest of I equal to 0, we didn't, he wasn't very polite in his code. I mean, I just randomly opened it, but anyway, he has this function, and in this function, he just has some iterator, and let me first see in here. So everything will be calculated in here, and then you can see out all the results and set initialize everything once again. So inside, first n minus equal to k minus 1, because the new array, as we discussed, is gonna have size k minus 1. Now we have an iterator while is if s of it was greater or equal to f of I it's minus. These are just some complex words with data structures. These are mostly, their complexities are in implementation. So he has a data structure, he's in init, he sets everything equal to 0, this one's to minus 1, f2 and t2 to minus 1, push id, l, and r. Okay, so he uses lazy propagation. And he will push things downwards. I see. And add. Okay, I believe this is when he wants to add one element to the end. Oh. And add in here is f of I plus equal to r minus l. So yes, I think he adds elements one by one, and he then, when he is at I, he tries to answer everything such that their R is at I. So he solved it in an offline fashion, and he just does something that I'm not going into some details, but maybe when the text tutorial comes, you can see the details of that in the text tutorial. But he uses some data structure. He makes that array that has the value that, has the number of operations to make an interval of length k to be consecutive, and then in that array he needs to, for some interval, he needs to sum up all the subintervals, for each subinterval, take the minimum of those elements and sum them up for everything. And that's also a kind of classic problem that I didn't go to the details, but it is solved in an offline fashion this way with this code. I'm sorry that it is not very precise, but that's what right now I can talk about. I hope that it helps you. Does it help? Was it clear for you? Can we use lazy operation in segment tree to add element to arrays from L to R? What do you mean by adding elements to some arrays, to few arrays? I didn't completely understand that. If there is an interval of arrays, I mean, because adding an element to an array does not have a unique definition. I mean, it matters that what do you exactly mean by adding the element. For example, you mean that add it to the right and what's changed on your array, etc. These are the important things. Not able to solve C. You can watch it. I mean, I explained it completely in my in this live. You can see it in here. I mean, in these parts, I was talking about problem C. I explained it completely. You can watch that. So about your question, actually, if I understood you correctly, yes, you can do that. You can add an element to some of the arrays, and it really depends on your operations, but in general, you can do that. I mean, there's nothing against that. In general, if the operations are okay, you can just do that. Yes, you can do that. Well, you can just, I mean, first of all, you can see that what is the solution of problem C, and you can implement that first, and then if you want, you can solve some similar problems. Maybe you can solve some problems with difficulty 1200, 1300, etc. and try to solve them. That would definitely work, and over time you get better. I mean, the main thing, as I said this many times over and over again, the main thing is about starting solving so many Codeforces problems, and that's so important. You need to accept so many problems, and this is very important. Expected rating of E, I'm not sure about it, but let me see. I think maybe 1700, 1600, 1700 maybe. That's what I guess. Okay, so I guess that we're done with everything. I also have to go to the university, and I hope that you enjoyed this video. Thank you a lot. I mean, if you liked the video, I would appreciate it. If you liked the video, subscribe to the channel if you want it. And you can, as I said before, you can always join our Telegram channel or a Discord server for further discussion. And thanks a lot for joining us today. I invite you to also attend our topic streams on Fridays. It's so nice to have you there as well. You can see the previous topic streams in this link, and I think that it would be nice to see you there as well. Sure, thank you very much. Thank you very much. I'm happy that you liked it. That's so nice. I'm so happy to hear that, and I hope to see you in the next discussions as well. Thank you very much, guys. Do not forget to see the previous episodes on topic streams so that you will be ready to learn. I mean, in this week, we're going to go to move on harder problems. I mean, we're going to have problem solving on graph algorithms. I think this session is going to be so cool. Hope to see you there, but make sure that before that you will see the videos for the previous ones as well. Sure, we will also teach, we will also discuss segment 3 as well. We are going on to topics one by one. First, we had only 3 topics on three lives on dynamic programming. Next, we're gonna have some live streams on graph algorithms. Then we will cover everything else as well, and also we will get back to DP and graph algorithms again and again as well. I hope that these are gonna be helpful for you. I think if you're at X rating, you need to practice problems at X rating itself. That's very important. Yeah, sure. Sure, thank you very much, guys. Hope to see you next time as well. Have a good day or night wherever you are on earth. See you the next time, guys. Goodbye.